Well, okay, I wanted to, thank you for those responses. I wanted to ask a question about the reactors. I want to come back to that just for a moment. Because I believe in the research, it shows that they're close to 25 years old, approximately.
Actually older.
Older, okay. So my question, my follow-up question is, have there been measures for improvement to it, as far as they're getting a little old? Have you started taking steps?
Yes.
To
Yeah, as I mentioned
conditions?
before briefly, but I'll kind of expand on right now. You mentioned the similarities between the designs of some of the plants that we have here in Illinois. Specifically, you're talking about the 2 reactors located at the Dresden plant and 2 reactors located at the Quad Cities plant.
Yeah.
And the similarities are really most direct when you're looking at the intercontainment facility, which is the GE Mark I.
Okay.
The rest of the facility has changed drastically over the course of time because ultimately significant improvements have been made to each of those facilities as technology has increased. So as the technology continues to get better, which to a certain extent we're kind of in the middle of what some people would refer to a nuclear renaissance as far as the efficiency of nuclear power, the capability to produce it, all those types of things, but there hasn't been a nuclear power plant commissioned in the United States in over 20 years.
Okay.
So what you're looking at is plants like the Quad Cities and Dresden. Dresden just celebrated 40 years this year. So it's a 40-year-old reactor right now. That being said, over that span of time, significant improvements have been made to the facility to make it more efficient, to make it better at what it does, make it safer. All of those things have been known over time. Now, the Nuclear Regulatory Commission had, basically when they commission a new plant, they give them a license for 40 years.
Okay.
That 40-year license expired at Dresden this last year and was renewed for an additional 20. The expectation is that the Quad Cities will get an additional 20 years next year, but really the youngest power plant in the state of Illinois is at Clinton. So as it happens, the closest one to us is the youngest facility in the state of Illinois.
Okay.
But youngest is kind of a dubious honor at this point because really you're talking it's over 30 years old.
Right.
So
Okay, yeah.
you know, really you're looking at a lot of plants now that have been online for several decades.
Okay. And let's say one of the quickest, let's say we've talked to Chief Goodwin and asked his opinion and all the wonderful measures that he has in place that appear to be that can be effective if something were to happen. Let's make it even simpler. If we were to have to power down a plant, are we prepared for that? And what measures would have to be in place? Are they in place? If we just needed to quickly power down, we see a lot of travesties that are going, that have occurred because of the safety elements didn't take on because they weren't able to power down very quickly. So where are we in that? Since we have 10, where are we as far as the powering down element?
Sure. Yeah, ultimately the plants themselves are actually designed to respond to an emergency by shutting down. Okay. But saying it's shutting down is definitely not flipping the light switch. I can tell you it's significantly more complicated than that process.
And how long of a process?
It's a very long process,
yes.
Really, in a lot of respects, because what you're looking at is you've got whether or not it's actually actively functioning as a reactor, as versus whether or not there's still radioactivity coming from the inner core and the spent fuel pool, and that's kind of 2 different things. So if you look at the earthquake that we had in Illinois just a couple of years ago, which is a very low magnitude, that actually caused the plants to shut down simply because if there's seismic activity in the immediate area, they'll automatically shut down right away.
Okay.
But what we're talking about too is it's not as, it's not, like I said, it's not like flipping off the light switch.
Yeah.
The other thing that you need to be concerned with, and this is what they saw in Japan, is, as I mentioned before, when you pull that spent nuclear fuel out, which is something that was raised and very, very accurately raised by the audience, when you pull those spent fuel rods out, they're still radioactive, very, very radioactive. And it takes a significant amount of time for them to ultimately cool down where the atomic reactions are not happening with the frequency or at the rate that puts out the heat and radioactivity that actually causes the problem. That takes 12 to 15 years. So
wow.
to put it in perspective, when they have a spent fuel pool, ultimately before it can actually be transferred to a low-level nuclear waste site, it takes about 12 to 15 years cooling down in water in order to actually slow down the reactions enough that you're taking away the harmful reaction that you're getting. So the first step, though, is making sure that the plant itself is shut down, because there are other issues that you can run into if the plant is still fully functioning at the time.
Okay.
How much of the shutdown process is automated versus human control?
And
It's
human
actually,
error.
yeah, really the
Dr.
human element is kind of the redundant element to it. Most of it happens automatically. And it's designed that way to
Interesting.
make sure that under no circumstances is it possible for, it cannot solely rely on human error, as you accurately identified. So the point is there's an automatic system that's in place, and then there's multiple redundant human systems that are in place. So you have the individuals who are physically at the plant, then you also have agencies like IEMA who are actually monitoring those plants that actually have the capability to do something as well. So ultimately it's, you know, if you look at an aircraft, the only way that you can actually fly an aircraft is that it actually has to have 6 redundant autopilot systems on a commercial passenger airliner. We take a very similar model. You have to have multiple layers of redundant capability to shut down those plants to make sure that under no circumstances can it basically run wild.
Okay, Dr. Daniels, what I'd like to do is have Dr. Daniels make his comment, then we're going to take a short break to come back with some closing statements. And I had one more serious question to ask before we have the closing statements, but Dr. Daniels.
I actually have another question. Going forward, you have new fuel coming in all the time,
Right.
and it takes 15 years to get rid of a piece of fuel. How often do they change over the rods, and therefore how much is piling up?
A lot of it just depends on, right now what you're looking at is you're looking at roughly over 9,000 pounds of low-level nuclear waste that's being stored somewhere in the state of Illinois right now at each of the plants. So it's distributed between each of the plants, even if it's inactive like the Zion plant that's on the North Shore of Chicago. So it's a great question because that's a national concern. That's not just an Illinois concern, that's a national concern because ultimately you cannot use those nuclear rods into perpetuity. At some point the level of their reactions is going to drop to the point where it's not efficient as a power source. So it's a constant process and it varies from plant to plant as far as how long they run one set of rods and then how long it's been since they've been taken out. I mean, at any one of the plants you can see the spent nuclear fuel pools contain rods that have been out for varying lengths of time. The real question that has to be asked at a national level is the Yucca Mountain facility was supposed to be the solution for low-level nuclear waste nationally. Unfortunately, it's not open. So what's happening now is each of the states are continuing to store low-level nuclear waste on site at each of the power plants.
Okay.
That's what Illinois has to do right now until a permanent solution is reached.
Okay, great. And, okay, hold that thought, sir, one moment. Hold that one moment, sir. We're going to come back with that question. We're going to take a quick break with Issues and Attitudes, Nuclear Safety in Illinois. Great. Welcome back to Issues and Attitudes, Nuclear Safety in Illinois. For the final question before we have our closing statements, I wanted to ask about the what if. We've been talking a lot hypothetically because we have to. We're fortunate that we haven't had some of the tragedies that have occurred in other countries. But I want to ask about, we've talked about the environment, we've talked about air supply, we've talked about water supply. What about the actual evacuation and movement of people? And what do they do? And what can they do? And not necessarily what can they do on an individual basis, but do we have plans and measures in place to actually get the word out to the people, educate the audience, and actually get them out safely?
Go ahead.
Sure. I would say the closer you live to a nuclear power plant, the more you actually know about this process because there's actually a requirement placed on how much information we need to put out. And it's actually shared responsibility with Exelon, who, as you mentioned earlier, owns the plants. But ultimately, I think you're hitting on the critical piece here, which is there are a lot of factors that we cannot control that we have to monitor.
No, yes.
The human element is the only factor that we actually can control, which is the evacuation plans and everything else that we have, because it can be just probably even more easily carried by people than it can be by really natural elements.
But you know, most of the residents here in Illinois are not used to evacuation en masse. If I can ask the audience a simple question, how many of you know what to do in a tornado? Okay, how many of you know what to do in an earthquake?
A little bit.
What do you know how to do for a nuclear reaction?
A nuclear reaction or radiation.
Yeah, one.
Thank you, sir.
Right.
But that was my key point. We all know about tornadoes, but
Right.
you know, but the reaction, nuclear reaction or a disaster. We don't.
Okay, that is a different.
Your company or your office for 4 years. I wrote the crisis relocation plans for the state. And I also wrote a hazard analysis for the state.
Okay, sir, I'm sorry. If you'd like to ask, we can't hear you at all because you're in the audience. If you'd like to stand to the microphone, if we have time, we'll get to that before we close. That would be fine, but we just can't hear you. Okay.